Hello and good evening for EST students. Good morning if you are in China. But this is Cloud Classroom G5, which is basically the grade 5 math class. If this is the class you're in, you made it. If this is not the class that you registered for, then you're welcome to stay, but you don't have to stay. Anyways, I do see a couple of familiar names. Hello, Fairwin. Hello, Derek, I think. And yeah, so basically for you guys, this is mostly going to be a review because you guys already learned this. And this course is just mostly for new students. But if you're an older student, you've taken this class before, it's fine. You'll still relearn and review some things. Welcome to the people that just joined. We're just starting, so you didn't miss anything. All right, so what is this class gonna be? It's gonna be 1 week from today. Today's Saturday all the way to next Friday. So we're gonna have this class every single day, and we're gonna learn stuff like distributive property today and order of operations. This is gonna be like the 5th grade class that I took. For the Chinese students, I know you might be a little bit more ahead, but this is the class that I took. So it might be a little easy for you. I know Chinese students are very, very tough on math. So if this is easy, then it's just review. So the primary features of Zoom, if you did not already know, is the mute, raise hand, chat, and camera. I'll go over more of that, more rules for that later on, but that's just to let you know. And this is me. I'm Jonathan Wang, if you didn't already know, and my teacher assistant, Alan, right here. He is going to assist me whenever you ask questions or I have any questions. All right, so this is G5 course created by me and Alan. Hello, winter class of 2020. If you took this over the summer, same thing. And before we get started, I want to talk a little bit about myself. I am currently in 10th grade at American Heritage in Florida. I've done a lot of after school math help, both at my middle school and my high school. If you're worried about if I'm good enough for you, I did pass 5th grade, which is the qualifications, I think. I started competing in math, like math competition, in 4th grade. I play the cello and some piano, and I have won a couple state/regional math competitions. And I do love teaching math. I love learning math, so it's perfect for both of us. And I have 2 cats. So a little bit about my TA, Alan. His camera's not on, but he's there. And he is basically super smart, a lot smarter than I am. He's basically placed higher than like 11th, 12th graders at our school. He plays clarinet. He knows a lot of Chinese. So if you mainly speak Chinese, if you have a question, he can help you with that. And yeah, he destroys every math competition ever. And he'll be grading and making your tests. So if you're not respectful to Alan, he'll be really hard on you guys. So just a word of advice. All right, so get on to the rules. I'm really relaxed with the rules. I don't really care what you do, as long as it's not disruptive to class. So basically, your camera does not have to be on. If you, for some reason, like your camera being on, sure, go ahead. I don't have a problem with that. Your microphone should be off during class when I'm talking. If you have a question, please raise your hand and I'll acknowledge you, or type something in the chat box. You can, about the chat box, you can type anything in the chat box as long as it isn't inappropriate or too off topic from what we're talking about. You can react, you can do whatever you want, but just try not to distract other students. So I would prefer English because I'm stronger at English than Chinese, but you can use any language during the break or after school. If you have any questions after school, come to me. If you find yourself struggling to understand what I'm saying, if I'm going too fast, maybe too slow, you start spacing out. If you want a general review of what I said, do the homework. Homework is recommended. Homework is very good. Even if you're really top of math, good review, I think so. And if you're new, it's a good learning experience. And most importantly, I want you guys to have fun. Math can be a very boring topic, I know, but under some circumstances, it can be very fun, especially in real world. Once you get into like really high levels of math, they become super interesting and you can apply them with like science, reading, which is really crazy. And yeah, so every class is going to be basically 1 hour. We're going to first do 30 minutes, and then once 30 minutes is up, we'll take a 5 to 10 minute break. I think we'll just take a 10-minute break because I know you guys probably just want more breaks. So 10-minute break for you guys, and then we'll do 30 more minutes. So basically a total of 1 hour, 10 minutes, 1 hour basically. And we have a total of 6 classes. So yeah. So in general, when I did this over the summer, I wanted to get to know you guys and get to know your emails and stuff so I can send you things. But I think Cloud is going to send me that instead. We don't have to do it, but I'll send this in chat just in case. So I know some of you can't use Google Form and Google, like China restricts Google. If you don't have a VPN, I would email this link. I'll type in the chat. Hold on. And Alan, if you could do the same. Basically, just email us, and we will get you the information you need. All right. I said we should spend 5 minutes on it, but to be honest, I don't. We're not going to spend too much time on this. All right. So before we do that, I want to just see, or you can see how far ahead are you in your math curriculum. So I designed a test. Hold on. I basically designed a test that basically checks your understanding of the 5th grade curriculum. So this is basically an overview of a couple easy questions, I would say, of the 5th grade curriculum. If you're having trouble with this, don't worry, I'm gonna teach you it. But if you're breezing through it, then you're ahead of the game. So I'll leave this up, and then after like 10, 15 minutes, I will move it to the second page. But total of 23 questions. I will leave this up, and at 6:30 we'll be over. So basically you have around 25 minutes basically to complete this, and yeah, that's it. So I will see you then. In the meantime, do these questions or take a break. Today's an easy day, so good luck with that. All right, guys. Looks like most of you are finishing up the first page. I'll move it down now. All right, so hold on, and I'll move it down. And then after 10 minutes, I'll review and then see how much you got right. Alrighty. It's around 10 minutes, and I think it's enough time for you to finish the second page. So you either take a break, or you can go ahead and let me share my screen. I'll go over the quiz right now. So the answers to the first question, number 1 is 40,000. Number 2 is 9,618. 3 is 273. 4 is 73. 5 is 43, remainder 2. 6 is 60. 7 is greater than. 8 is 0.9. 9 is 12.00 in 09. 10 is 11.07. 11 is 0.0437. 12 is 21.3. 13 is 12. 14 is 7/8. 15 is 1/12. 16 is 2 and 17/24. 17 is 8. 17 is 10. Sorry. 18 is 15.2. 15/2. All right, and then for this one, the answers were 10 and 20. And number 20 is quadrilateral. Number 21 was acute. Number 22 is isosceles. And number 23 is 40. So hopefully you tally up your score and you know how much you got correct, how much you got incorrect. It's fine if you got a low number, because this is all stuff we're going to be learning. If you don't know this, it's fine, because you're not supposed to know this. But if you do, good job. Yeah, Angelina, if you have a conflict, go ahead. You can leave. It doesn't really bother me, but yeah. All right, so currently you can take a, let's say, like 5-minute break. Come back at like 6:37, and then we'll continue. So I'll see you then. All right, so 5 minutes has passed, and now we're going to go on with chapter 1. Today we're going to be learning place value, multiplication, and expressions. So that's just fancy words for order of operations, multiplication, and easy stuff. Like I said, today is going to be pretty easy because it's the first day. We're just going to be learning one chapter, and it's chapter 1. I'll review stuff. So place value. I know some of you, I think some of you are also in my G4, grade 4 class. So this is all familiar to you. Place value is what we're going to be learning right now. So all humans, all of us, me, you, your mom, your dad, all use the decimal system. So what does that even mean? Decimals, isn't that like 1.2, 1.35, 0.67? Those are decimals, but the decimal system means that you count by 10. So most people think that we count by 10 because we have 10 fingers on each hand, and 10 toes. But that's the general reason why we use the number 10. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You count from 1 to 10, 10 to 100, 100 to 1,000. And you're like, obviously, that's how I've been counting my entire life. But you have to also note there is a separate system. Many different systems. So we count in, so the decimal system, we can say is base 10 because we count in tens. But you see this weird number sequence: 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 0, 0, and so on. So basically, this is counting by 1, 10, 100, 1,000, but it means that we're counting in binary system. This is the binary system, by the way. Computers use this to count. Humans use the decimal system, which is up here, to count from 1 to 10. And the decimals, they use computers use binary, which counts from 1 to 10. And I don't know if you believe it or not, but this is the number 10 in binary. This is the number 100 in binary, and this is the number 1,000 in binary. Pretty neat. And we can use this knowledge of the decimal system to come up with place value. So if I give you the number 23, there's nothing too interesting about it, but I can break down 23 into 2 tens and 3 ones. So if you have 10 blocks and I gave you one of these blocks, I gave you another blocks, combine them, they're 20. Now you have 20 blocks and I give you 3 ones. So I have 2 tens and 3 ones. How about 8,419? I want to find the place value of 8. Well, what place is it in? The 9 is in the ones place, the 1 is in the tens place, 4 is in the hundreds place, and 8 is in the thousands place. So if we wanted to find the place value of 8,419, the place value of 8 is thousands because it's in the thousands place. The place value of 4 is 100 because it's in the hundreds place. The place value of 1 is 10 because it's in the tens place, and the place value of 9 is 1. All right, so how about number value? We went over place value, which is the position it's in: 1, 10, 100, thousands, 10,000s, a million, so on. But how about the number value? It's basically the same concept. So let's say I have the number 107. Nothing too special about it. It's just a weird number. So let's break it down. 1 hundreds, 0 tens, and 7 ones. So we just broke it down. But it's different from place value. Oh, hold on. It's different in place value in that it's actually a number now. So 1 hundreds is 100, 0 tens is 0, and 7 ones is 7. So the number value of each number is dependent on its place value. So 107, I want to find the place value of 1, it's 100. But it's also the number value, which is also 100. How about the place value of 7? The place value of 7 is 1 because it's in the ones place, but the number value of 7 is 7 because it's 7 ones. How about another example? So I have 12,154. I want to find the number value of 5. Well, the 5 is in the tens place. That means the number value is 50. And I gave you a bunch of other numbers. So the place value of the first one is 10,000. the place value of the second, the first two is 2,000, and so on. So how about this number, 361,252? You could break it down into its key components and find out that 3 is in the 100,000th place. So the answer is 300,000. Pretty simple stuff so far, hopefully. So some practice problems. I'm gonna go through these with you so you guys don't have to do them. They're all pretty easy stuff. But the first column on the left here is the place value. I want you to find a place value. And the column on the left, on the right, is number value. So looking at question 1 on the left side, how do we do it? Well, place value, if you remember, is the position it's in, the ones place, the tens place, or hundreds place. Well, if 7 is in the ones place, that means 2 is in the tens place. And how about the second question? 8,467. I want to find the place value of the 4. So the 7 is in the ones place, 6 is in the tens place, 4 is in the hundreds place. Crazy stuff. How about number 3? Well, 1 is in the ones place, so we just say it's in the ones place. And then 4, for number 4, is we want to find the place value of 2. Well, 7 is in the ones place, 0 is in the tens place, 9 is in the hundreds place, 2 is in the thousands place. So the place value of 5 in 500,100 is how many times more than 1? Okay, so we find the place value of the 1 first. So 0 is in the ones place, 0 is in the tens place, 1 is in the hundreds place. So that means 100 is in 100 is the ones is where the 1 is. How about the 5? The 5 is in the 100,000th place. So it's 100,000 compared to 100. So we just count the number of zeros. So it's going to be 1,000 times more. So I basically did the exact same questions on the right side to basically show you. So on the left, we calculated that 2 is in the tens place. So that means on the right side, the number value of 2 is 20. And the number value of the 4 is 400. The number value of 1 is 1. The number value of 2 is 2,000, and so on. Okay, so how many different ways can we write numbers? So basically, we can write numbers 3 different ways. So we have standard form, word form, and expanded form. And I'll show you what those are. So standard form is the way you normally write numbers. So you write 4 like a line like that. You write 3 like a half 8. You write 1 as a line. That's standard form. You look at this and you're like, that's a number. But what does that even mean? Word form is how you say a number. So if I write a number like this, then the way I say it is its word form. So 262,400. That's how I say it. But you write it like this. You write the 2, the 6, the 2, and so on. And expanded form. This one's not used as often. Like you just make the number expanded, basically. Nothing too special about it. Okay, so properties. We have 3 properties: commutative, associative, and identity. So what does that mean? Addition and multiplication have all of them. And then one of them combines both of them, which is distributive. But these are all a lot of words. I know it's a lot of words. So don't worry about it. I'll explain it later. So I'll tell you some examples. So let's start with addition, right? So we have addition properties, and we have the commutative operation. What this means is that in addition, if you add 2 numbers, a plus b, it equals b plus a. So you can switch around the numbers. Like, for example, if I add 3 plus 92, I'll get 95. If I add 92 plus 3, it's 95 as well. So that means when you flip around the numbers in addition, it doesn't matter because it's always going to be equal. That's what commutative means. You can switch the numbers around and you will get the same answer. Associative. This is a little bit more trickier because it involves parentheses. So this property is basically saying if I have addition and I do AB first and then plus C, it's the same as adding BC first and then adding A. So for example, I have 1 plus 3 is 4, plus 6 is 10. How about 3 plus 6? 3 plus 6 is 9, plus 1 is 10. So that means you can move the parentheses around and it will be the same. And the identity. What that means is A plus any number plus 0 equals A. So the 0 is the identity number. Any number, no matter what number you choose, no matter how hard you think, it will equal 0. So let's say you choose 1. 1 plus 0 is 1. How about 13? 13 plus 0 is 13. How about 1,500,000 plus 0 is 1,500,000. So any number plus 0 is going to equal the same number. So A plus 0 equals A. That's what it's saying. So this is all stuff that you might be like, obviously that's true. I know this because I do this all the time. But in higher fields of math, commutative, associative, and identity don't exist. Maybe in number theory or abstract algebra, these things don't exist. Some operations don't exist. Like division. Division is a good example. That this does not work. Commutative does not work. All right. How about multiplication? So we just did addition properties. How about multiplication? Commutative. The same thing works. If I have two numbers and I multiply them together, if I swap them, it's going to be the same. So for example, 6 times 8 is 48 is equal to 8 times 6, which is also 48. Pretty simple stuff. If I multiply 1 times 3 and I multiply 3 times 1, the same thing. I can just swap them and it doesn't matter. How about associative? Same thing. I can just move the parentheses over and it will be the same. For example, 4 times 25 times 30 is equal to 3,000, no matter what parentheses you use. And the identity, which is times 1. Any number times 1 is itself, no matter how hard you try. You can choose this big, gigantic number that I put here. Let me try to read it. 1,095,837 times 1 is the same number. So no matter what number you choose, times 1 always equals that number. And that's the identity property. So that's basically the properties for both addition and multiplication. They're not true all the time, especially for subtraction and division, but they're true for addition and multiplication, and that's important to know. So what is a distributive property? It involves both addition and multiplication. So I need both addition and multiplication to do it. So distributive is A times B plus C is equal to A times B plus A times C. That's the basic definition. It's hard to describe why, but that's the definition. So for example, 5 times 5, right? We know it's 25. But what if I wanted to split the 5 into 5 times 2 plus 3, right? It's still 5 times 5, but 5 is 2 plus 3. Then I multiply 5 times 2 plus 5 times 3, and I will get 10 plus 15 equals 25. This was a very, very important property, especially when you get to algebra 1, algebra 2, and so on. You'll need this. It's fundamental that you know distributive property. But you have to be careful. When you do addition, it does not work. 5 plus 9 times 6 does not equal 5 plus 9 times 5 plus 6. It only works if it's multiplication outside and addition inside. You could try for yourself. This side is going to be equal to 59, and this side is going to be equal to 14 times 11, which is not 49. All right. So yeah, it's 154. 59 is not equal to 154, so that's not true. All right, so that's basically to show you, but yeah. So I'm going to show you a little bit more examples on distributive property. So 9 times 30 plus 7. It's 9 times 37, but I want to split it up to make it easier. Well, I multiply 9 times 30 and then 9 times 7. I'll get 270 plus 63. And I'll get 333. It's very hard to calculate big numbers in your head. Like if I gave you like 12 times 20, you could be like, oh, I don't know. But you could do 20 times 6 plus 20 times 6, and you'll get your answer, which is 240. So basically, this is very useful for splitting it up. See, 9 times 30 is easier than 9 times 37. And 9 times 7 is just 63. So these are the properties. So what properties are they? Well, the first one is identity, because 0 plus anything is equal to itself. So let's say if I plug in 1, 1 plus 0 is equal to 1. 0 plus 0 is equal to 0. So it's the identity of addition. How about this next one? This next one looks a lot like a distributive. And if you check the math, it works. So this one's distributive. How about the next one? 4 times 1 is 4. What property does that look like?
Identity.
Identity of multiplication. Oh, Catherine, you might not have muted. Oh, yeah, there you go. Thank you. Number 3 is 4 times 1 is equal to 4. That's identity of multiplication. And then 4 plus 0 is equal to 0 plus 4. We swapped them around, which means it's commutative. And we see for number 5, we see the parentheses have been moving. So that means it's associative because the parentheses are moving. And then for the last one, for number 6, I meant we swapped 2 terms. So what does that mean? When we swap 2 numbers, it's commutative. And then the last one, 1 times 0 equals 0. This one you might be like, oh, identity of addition. But you see the multiplication, identity of multiplication. Remember, anything times 1 is itself. So 0 times 1 is 0. 1 times 1 is 1. 1 times 2 is 2. So exponents. This is the last thing we'll do today. Exponents, you might be like, oh no, what are exponents? They seem those big words. So like, oh no, what is this? 2 to the power of 3, 123 to the power of 1. So multiplication in addition is the same as exponents and multiplication. What do I mean by that? So 10 times 3 is equal to 30, right? 10 plus 10 plus 10. Well, 10 to the 3 is equal to 10 times 10 times 10. So it's basically just multiplication a bunch of times. This number, the 10, tells you the number you're multiplying by. And the 3 tells you how many times. So if I have 10 to the 4, it's 10 times 10 times 10 times 10. 10 times 10 times 10, 4 times. If I have 5 to the 6, it's 5 times 5 times 5 times 5, and so on. So exponents mean a number is multiplied a certain amount of times. So for instance, 10. 10 to the 1 is 10. 10 to the 2 is 10 times 10. 10 to the 3, 10, 10, 10, and so on. So you might notice a pattern. 10 to the 1 is 10. 10 to the 2 is 100. 10 to the 3 is 1,000. 10 to the x is 1 with x zeros. So for instance, if I have 10 to the 1, the answer has 1 0. 10 to the 2, the answer has 2 zeros. 10 to the 3, the answer has 3 zeros. And if you look at this picture, 10 to the 4 has 4 zeros, 10 to the 5 has 5 zeros, and 10 to the 6 has 6 zeros. Very interesting fact. So if you think about it, what is 10 to the 0? Well, from the picture, you can see that it's 1 because it has no zeros. Therefore, 10 to the 0 is 1. Yeah, it's 1. So now you are very smart. You know what exponents are. You know what the properties are. Basically, this is a math problem involving scientific notation, which is basically stuff that you'll use in science class like chemistry or physical science. So my backyard is 90,000 square kilometers. And how can I say this as a whole number times a power of 10? So 9 times which exponent? Neat little trick. We count the number of zeros. 1, 2, 3, 4. And the answer is indeed C, 9 times 10 to the 4, because there are 4 zeros. Very good for the people that got that right. I know we're breezing through this. So now we have a lot of knowledge. So 30 times 600, how do you do this? How do you do big numbers? So we know that 3 times 6 is 18, right? Everyone knows this. Pretty simple stuff. And then we can split up 30 times 6 into 3 times 6 times 10 to the 1. 300 times 6, 3 times 6 times 10 to the 2. 300 times 60 is 3 times 6 times 100 times 10, which is going to be 18,000. Pretty smart stuff, eh? So for higher and higher numbers, it becomes very long and very hard when you multiply. Like for instance, 293 times 9. Very, very hard, like mentally. So we'll go over this and then we'll end the class for today. But multiplication, 293 times 6. Well, first we do 3 times 6 first, which is 8. Then we move the 1 over to the next number. So when you add it, you add 1 to the number. So what is 9 times 6? 9 times 6 is 54. And then we have the extra 1. So we add it. So it's 55. So we bring that 5 over there. And we put 5 over the 2. And then what is 2 times 6? It's 12. And then we add an extra 5. And then we'll get our answer, which is 17. So the answer is 1,758. So in general, I think you guys know how to do multiplication, especially at your level. But basically, that's what we had to learn in 5th grade as a review. But mostly, I think it is time. So that should be it for now. We had a little bit more to do. We'll do it next time. We'll do it tomorrow. But for now, I will see you next time. So class is over for now. And you guys can leave. Come back tomorrow. And I'll see you then. So see ya.